Okay, we're going to start chapter 9. It's going to be just kind of an introduction. This is review, things that you've seen in some of it in middle school, some of it in Algebra 1, some of it in geometry, but it's something that is very important for our trigonometry chapter 9, which will be a big chapter. Okay, let me get the pen going here, and then we'll get to it. Okay, so the Pythagorean theorem, remember, it is very important that you always identify the hypotenuse is opposite the 90-degree angle. These two acute angles will always add up to 90 degrees as well. And then these two legs, they're kind of interchangeable because we're just adding them together. And a squared plus b squared equals c squared, something that you've used for a long time in your math career. So when we're looking here, it doesn't matter which ones I assign A and B. I got 12 squared plus 16 squared equals c squared. This is 144 plus 256 is c squared. I get 400 is c squared. Square root both sides. C is 20. Okay. When the three sides of a right triangle are all whole numbers, that's called a Pythagorean triple. So we'll deal with some of these Pythagorean triples where we get nice answers like the square root of 400. And we'll also deal with some that we have to do simplified square roots. Make sure you read directions carefully. Do you want simplified square roots that is exact values, or do you want a round? And we'll do both. Over here, a few different ways you can do this. You can write the equation a squared plus 12 squared equals 13 squared. You can also recognize that if you're given the hypotenuse, you're always going to be subtracting, because I'm really going to do minus 12 squared, minus 12 squared. And I do 13 squared minus 12 squared on my calculator, which is 169 minus 144, which is 25. And that's another nice perfect square, and I get a is 5. So this is a is 5, and I get another Pythagorean triple. Okay, so we've got a 5, 12, 13 there. Multiples of Pythagorean triples are also Pythagorean triples because we're talking about similar triangles. Okay, and over here, I would actually just do 15 squared minus 10 squared equals b squared. You can skip right to that. You don't have to put it into the basic equation. There's nothing wrong with recognizing that's c and that's a, so I know I'm going to be subtracting. Either way would work. And this is 225 minus 100, and I get 125 is b squared. And at this point, we are at the juncture where that is not a perfect square. So now, if they were looking for the rounded, I believe it's like 11.1 or 11.2. If you're looking for a simplified square root, remember, we break down square roots as the square root of 25 times the square root of 5. You're looking for perfect square factors. So we would do 5 root 5 on this one, and we're set. Real world example. We could say Seth's making a table, and he's got a table that is measuring 36 by 18. He measures the diagonal, and he gets 43, and he wants to know, is that square? Now, that doesn't make it's a rectangle, obviously. Square means that we have right angles, okay? Square means we have right angles. So I would just check 36 squared plus 18 squared, because the diagonal would be the hypotenuse. And I would type that into my calculator. 36 squared plus 18 squared is 1620. And I would take the square root of 1620, and I get 40.25. So if this was going to be the diagonal, so this would be 18. If it's a right angle, it has to be 40.25. This is not a right angle, so therefore he does not have a square table. He's going to need to sharpen some of his measurements up there and make it into a right angle. Okay, special right triangles. We're going to do 2 special right triangles today. The first one we're going to do is a 45, 45, 90, often referred to. It's also known as an isosceles right triangle because I have 2 sides the same length. It's also called a 1, 1 square root 2 because the ratio of the sides simplify down to a 1 and a 1 and a square root 2 for all 45, 45, 90s. Okay. Let's see here. I gotta. Where's my deal here? Okay, sorry for the delay there. All right. So we said this is often called the 1 square root 2 because that's the simplified form. And if you take a look at a 1 square root 2, if we did the Pythagorean theorem, 1 squared plus 1 squared equals, and I get 1 plus 1, and I get 2, and these are equal to c squared, right? So now when I take the square root of both sides, I get the square root of 2. So that's for every isosceles right triangle. We will be able to do this. So the hypotenuse is the square root of 2 times the leg. So we do x, and then x times the square root of 2. Very easy going this direction. If my leg is 13, my other leg is 13, this is 13 times the square root of 2. It checks out too, because if you're going to do 13 squared plus 13 squared, 169 plus 169, and I'm going to end up with, what is that? What is 160? Well, 170 and 170 would be 340, 368. 348, 3 what? 160, I need a calculator. 338, holy cow, doing great. 338, and then if that's equal to c squared, I take the square root, and I have the square root of 169 2 times. Oh, 2 times. That's where the 13 root 2 comes from, and it will come from that every time. Okay, now I'm going from the x root 2, and I'm going to divide by the square root of 2. Well, dividing 9 root 2 by the square root of 2, it just goes away. You can almost see it. X root 2. X is 9. Those ones are easy. This, if you stop paying attention, start paying attention right now. If this is the x root 2 side, what are we going to do? We're going to divide by root 2. I don't expect you to write this equation each time, but some students do. I'm going to take the 28 and I'm going to divide by the square root of 2. But here's the thing. We are not allowed to have an irrational number in the denominator, so we have to get this out of there. How do you get a square root out of the denominator? How do you set it free? You square it. Well, we can't square it in this case, but we can do the same thing, which is multiply it by itself. Whatever you do to the bottom of a fraction, you got to do the same thing to the top of a fraction. And I end up with 28 root 2 over 2. If this is even, these can be reduced. This can be 28 over 2, which is 14 root 2. Some of you will start to realize that what we're doing is we're dividing by 2 and then multiplying by the square root of 2. That's exactly the same thing as dividing by the square root of 2. But going through the process is the safest way, at least at the beginning, while we get our bearings on these special right triangles. So I look here. I have this side now. So sometimes they try to goof you with this guy. Again, we have to be told it's a 45, 45, 90, or that these two sides are the same. And then we can use this. So I'm going to take my 7 root 2, and I'm going to multiply it by the square root of 2. This is the x side. I'm multiplying it by the square root of 2. Square root of 2 times the square root of 2 is 2. 7 times 2 is 14. That side's 14. That's 7 square root of 2. Again, these two are the harder ones that we have to do. If I'm given the x root 2 and I'm going backwards, I'm going to divide by the square root of 2. I'm not allowed to leave it like that. I need to 9 root 2 over 2, and I'm done. So 9 root 2 over 2 for both of them. This is a square, and they've given me the diagonal, and they've said that it's 45, so I know it's isosceles. And that means that I'm going to take my 24, and I'm going to divide by the square root of 2. Again, I'm going to go here and here, and I'm going to get 24 root 2 over 2, 24 over 2, 12 root 2. So these sides are 12 root 2 all the way around. Okay, that's our 45, 45, 90. Now we're going to do the 30, 60, 90. So when we did the 45, 45, 90, we didn't care which of the legs I was talking about because they're the same thing. Now it's going to be very important that you understand the orientation. That is, where is the 30 and where is the 60? So these are called the 30, 60, 90 triangles, and they're often referred to as the 1, 2, square root 3. Whoops, 1, 2, square root 3. Dashes between them. Because they set up like this each time. Across from the 30 is 1, across from the 60 is square root 3, and the longest side is 2. Remember, the square root of 3 is actually less than 2. It's 1.7. And if you can't remember that, remember 2 is the square root of 4, and the square root of 4 is bigger than the square root of 3. You're always going to work off the 30-degree angle, okay? The 30-degree angle is kind of the winner because you're going to double it to get this one, okay? And you're going to multiply by the square root of 3 to get that one. So if you know the hypotenuse, you're going to divide by 2, and then you would multiply by the square root of 3. The hardest ones are when you know the side opposite the 60, because here we are again. How do you go backwards from that? You have to divide by the square root of 3. So let's look at some examples. The first thing I do is I would also like to point out that you must be told it's a 30, 60, 90. Must be labeled. Otherwise, people assume that Pythagorean theorem problems are automatically 30, 60, 90 problems. Don't be that person. Okay, how do we go from the side opposite the 30 to the hypotenuse? Looks like we double it. This is 1 square root 3. This is 2 square root 3. How do we go from the side opposite the 30 to the side opposite the 60? We take it and we multiply it by the square root of 3, which makes this 3. Okay, so this side is 3. This was root 3. This is 2 root 3. Over here, identify your stuff. This is the hypotenuse. That's the 2x. How do I go backwards from 2x to 1x? I divide by 2. And then I multiply times the square root of 3. And you can really see it here. 9 root 3, 9 times 2. These ones are really pretty simple when you're given across from the 30 and you're given the hypotenuse. Of course, we have a catch, right? Because this is the x square root 3 side, or the square root 3 side. This is the x and this is the 2x. How do I go backwards from x square root 3 to x? I have to take the 10, I have to divide by the square root of 3. Am I allowed to leave it like that? I am not. So I multiply the top and the bottom by root 3 over root 3. Why do I do that? I do it to set this free, and I also do it because multiplying by the number 1, root 3 over root 3, is legal. And I get 10 root 3 over 3, and this is 10 root 3 over 3, and then I have to double that. Well, how do I double something like that? How do you double a fraction? You multiply it by 2. Please remember, you're only doubling the top number. It's times 2 over 1. 10 root 3 times 2 is 20 root 3 over 3. Okay, so you really need to focus. Number 1, is it a 30, 60, 90? Number 2, how do I get to the side opposite the 30? That is your key, because you look here, 2 times the shorter leg is the hypotenuse, square root 3 times the shorter leg is the longer leg, or opposite the 60. So your focus is the shorter leg. Do that first. Your life gets easy. Couple of problems. First of all, it says this is a square, and if this is a square, that means it's a 45, 45, 90, which means you're doing this, we're dividing by the square root of 2, so I get 14 and 14 and 14 and 14. And you got to read the problem carefully, and this is going to come up in your homework as well. Make sure you read the directions, because this one says find the perimeter of the square. So often we get people who say 14 on this one. No, it's 14 times 4, which is 56 for the perimeter. Also, take a look down here, this number 14, it says it's a rectangle. Anywhere on this problem does it say this is a 30-degree angle? No. People look at this and they assume 30, 60, 90, and things go bad. All right? So if we're finding the perimeter of the rectangle, that's 9, that's 9. What do I have to do? I need to find this missing side down here. Let's call it A. So I'm going to do A squared equals 15 squared minus 9 squared. A squared equals 225 minus 81. A squared equals 144. Root A is 12. Again, you cannot assume 30, 60, 90. Very important that you pay attention to that. And now I got to find the perimeter of a rectangle is 2 12s and 2 9s for a total of 42. Okay, find the altitude of this equilateral triangle. First things first, we got to know some stuff. Equilateral triangle means all the sides are the same length. Also means all the angles are the same length. Altitude means it forms a right angle. It also means, if you remember back to the altitude of a equilateral triangle, means this is the perpendicular bisector, which means that's 30 and that's 30. Isn't that great? So really, I'm talking about a 30, 60, 90. If I just cut the 12 in half, How do you go from the hypotenuse to opposite the 30? Cut it in half. Well, that shouldn't be a surprise because this whole side was 12, and we just dealt with that. We divided it by 2, no big deal. And then we multiply by the square root of 3. How do you go from opposite the 30 to opposite the 60? It's times square root 3. Find the altitude. It's 6 square root 3. Oh, nice looking 3 you got there. Please make sure that you're paying attention on your homework. There are kind of 2 worksheets. The first one has to do with the Pythagorean theorem. A squared plus b squared equals c squared. And I think the directions might say round to the nearest tenth. Please do that. That's on the first worksheet. Also on the first worksheet, I think the answer to number 1 is 15.3, and there isn't a place to cross that out on the back because it says 15.0. Somebody omitted the 3. Please make note of that. Also, I just told you an answer. Hopefully you get the right thing. And then the second worksheet has 30, 60, 90s, and it says also says cross out the correct answer. So please make sure that you are remembering your isosceles right, 1, 1, root 2, x, x, x root 2, and your 30, 60, 90s, 1, 2, square root 3. Always work off of this one, right? Always off of that one. Go get them.